Hey everybody, Mrs. Bianchi. We're looking at, I think this is number 10 or 11. Juanita is making necklaces to give as presents. She plans to put 15 beads on each necklace. So this, I think it has 12 beads, but we can just throw a few more, pretend it has 15. So 15 beads for every one necklace. All right, it says beads are sold in packages of 20. Now, I don't know how many are in here, but let's just pretend it's 20 that are in here. I didn't actually count. This is just so you can visualize the situation. What is the least number of packages she can buy to make necklaces to have no beads left over? So when you see the words least number of, that's red flag for this is probably an LCM question. So let's proceed with finding the LCM of 20 and 15. And in this case, let's try the prime factorization method because we've discussed a couple different ways you can do this in class. So when we use the prime factorization method, we start doing factor trees. Now, it's a good idea to try to speculate what the GCF of the two numbers is, and I think that might be 5, so I'm going to put that in both factor tree lineups. And then you ask yourself, well, what would the other factor be? And it would be, in this case, 4. Over here, in this case, it would be 3. Now, this tree is done because these are both prime numbers. This tree, we can keep going. 2 times 2 equals 4, and if we bring down the 5, all right, so this is the prime factorization for 20. This is the prime factorization for 15. When we go to organize it on our Venn diagrams, we'll make this circle will represent the prime factors of 20 and the other number is 15. So we'll make another circle, color code it. We'll make it in blue. And this will be for 15. And we're going to look for numbers that are in common. So what's in common? The 5 is one that's in common. And that's the only thing that's in common. So if we were interested in the GCF, we would say that it's 5. Now, what are the numbers that they don't have in common? We have the couple of 2's here. So let's use green to write those in. Now, remember, everything in the red circle, the 2, and the 5, you have to have the same numbers, not necessarily in the same order, but you have to have them in the yellow circle. So see, I have a 2, and a 5. We have the 2 with the 2 and the 5. So we're good with the red circle. For the blue circle, we have to have everything that we see in this yellow circle right here. We already have the 5. The thing we're missing here is the 3. All right, so to find the LCM, we just have to multiply all of these values together. So we can use compatible numbers, like we might take these two things here and say that that's 10, and then we'd multiply in the 2, and then we multiply in this 3. 2 times 3 is 6, and 6 times 10 would be 60. Now, the order that you multiply that in should be based on what you can do in your head. So the LCM is 60. Now, if you just took the numbers, went across on a calculator and just did 2 times 5 times 3, that would have been perfectly acceptable. Now, another thing you may have discovered in class is if you know the GCF, which is 5, if you know the GCF, let me circle that. This is the GCF, which is 5, and I'm going to put that number up here. And you know what your other factors are that you would multiply with the GCF to get that number. So in this case, it's 4. And in this case, it's 3. If you take the product of these two green numbers, that would be 12. Now, if you do, what would you have to do with the 12 and the 5 to get the answer, which, by the way, we know is 60? The answer is we'd have to multiply those two things. And that's a shortcut way to get the LCM. So let's just review that little shortcut. If you're able to identify the GCF, you take the other factors, which are 4 and 3, multiply them together and get 12, and multiply it in with the GCF, and that's how you get the LCM in shortcut method. But if that's over your head and you don't understand that, then just press on with doing the Venn diagram and organizing your work that way. All right, but we're not done with the question. We know the GCF is 60. Now, the question is, they're asking us what is the least number of packages. So we're trying to figure out how many of these we need to buy. Because remember, they come in packages of 20. So if this is 20 and we duplicate this, right? We duplicate it. Let's clone it. Now we have 40, right? Because there's 20 more, that makes 40. What if we clone it? What does that make? Now do we have the 60? Is this 60 altogether? It is, right? So how many packages are there? 3 packages, right? Now, if we didn't have the nice pretty picture to look at, how would we get that number of 3 packages? Well, we had the LCM of 60. We know that they come 20 in a pack. We would do 60 divided by 20, and that would give us this, or 3 packages. Now, sometimes they might ask you how many necklaces can you get out of that. Now, it doesn't say anything about necklaces, right? They don't want to know how many necklaces, but if it did ask for that, then we would have to keep, going with this. So now we're up to 30, right? Because 15 times 2 is 30. If we clone this one more time, now we're up to 45. If we clone this one more time, now we have 60 beads on our 4 necklaces, right? They didn't ask how many necklaces, but if they did, then we would say 4 necklaces. But they asked for packages, so this is your answer.